Before we begin with the chapter itself, we need to recall few things. The very first thing is the equations of motion. So what are the equations? Please pause, write it down on a sheet of paper, and you also have to talk about the variables that being used in the equations of motion. Okay, so please pause and have a go. I hope everyone tried. So the very first equation is v is equal to u plus at. Second one is v square is equal to u square plus 2as. Third one is s is equal to ut plus half at square. These are your equations. I hope most of you got it. The next thing is, what do they stand for? What does v stand for, u stand for, a stand for, and t stand for, and s as well? You need to recall that as well. So please pause and have it a go. I hope you guys tried it. V is your, yes, final velocity, while u is your initial velocity. A is your acceleration and t is your time. The only thing that left out is s, that's your displacement. Again, you need to recall a formula in this manner, what they stand for and what is the equation. So please don't miss out what they stand for. People memorize, but they don't understand what they stand for. End of it in exam, they won't be able to use it. What's the point, right? The next thing is laws of motion. My first question to you guys is, how many laws are there? Answer is, there are 3. Newton's law, there are 3 of it. What do they stand for in terms of force? What do they stand for? Try to recall, what do they stand for? The first law talks about when there is no force, what happens. The second law talks about when there is a force, what happens. Right? When the net force is non-zero. To be more accurate, we're talking about net force. Third one talks about what happens to the object that is applying the force. Right? So these are your first 3 laws. The 3 laws. So what is the first law state? Can you recall that? Okay, I hope you guys are trying. The first law talks about an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. Right? What does it mean? I have a diagram for you guys to explain that. If an object is at rest, that is u is 0, even after some time, it will continue to be at rest. We see this day to day. If you keep a pen over there, it will be there. Say it was already moving and there is no unbalanced force acting on it. Even after some time, the velocity will not decrease. This is something which we don't see day to day, right? In our day-to-day life, we have friction that will stop any moving object. But yes, the law tells this, and this is observed in nature. Of course, not on a day-to-day basis, but yes, outside Earth's surface and all of that, right? Next, an important conclusion regarding this too is that the acceleration is 0. Okay, so first law talks about when there is force, when there is no force, the acceleration is 0. Second law talks about the acceleration because there is a force. That is, there is a net force, either positive if not negative. The acceleration of an object depends on the mass of the object and the amount of force applied. What does that mean? I have explained with this 2 set of diagrams. The first diagram talks about 2 scenarios. The scenario is this. We have 2 objects of the same mass. For the first object, a force of F1 is being applied, and for the second object, a force of F2 is being applied. F1 is lesser than F2. Okay, so this is your scenario. What happens to the acceleration? The acceleration A1 will be lesser than A2. Common sense. If you apply less force, the object will move less. As simple as that. The second picture talks about again two scenarios. Here we have M and capital M. Those are your masses. That is, the mass of the smaller object is lesser than that of the bigger object. But we are applying the same amount of force. What happens to the acceleration? The acceleration of the first object will be greater than that of the second object. Why? Common sense again. If I apply same amount of force to a car and say to a ball, obviously the ball will move faster. Right? All this is commonsensical. So this is something that you guys have to understand and know. And so we have the formula A is equal to F by M, as F is directly proportional to acceleration and mass is inversely proportional to acceleration. Quite simple, right? First law talks about no net force. Second law talks about non-zero net force. It can be either positive or negative. Okay, positive and negative. How can a net force be negative? That I've shown you. I've spoken about that particular scenarios, those particular scenarios a lot in the previous chapter, right? I hope you guys have seen that and come over here. The third law talks about what happens to the guy who applies the force. Whenever one object exerts a force on the another object, the second object exerts an equal and opposite force on the first object. What does it mean? Here, this person is pushing this object. What happens over here? Well, this force is called as action and the object will push back. That's called as reaction. Again, the person is pushing the object will in turn push the person back instantaneously, immediately. There's no time delay. But what's so special about this? Well, the forces are of equal magnitude. That is, the strength is the same, but in opposite direction. The action force and the reaction force are equal in strength, but opposite in direction. Action force acts on one object, reaction force acts on the other object. So all these differences and everything I have spoken of till now. I hope you guys have studied all of it till here. If not, well, it's going to be difficult to solve numericals and so on and so forth. Okay, so this is your first, not first, these are your laws of motion. Then we have a terminology that we need to know, that is your tangent, the word tangent. So we are considering a circle. A tangent is a line which touches the circle at a particular point, at a single point. See, if we ask to draw a straight line on this particular screen, I can draw it this way, I can draw it this way, and I can draw it this way, right? With reference to this circle, I have this three possibility, wherein the first line does not touch the circle, second line touches the circle at two different points. So this has a special name known as secant. The third line is a particular scenario wherein the line is touching the circle at a single point. Such a line is called as tangent. Why is this important? You learn as and when we go, but you need to know this. A straight line that meets the circle at one and only one point is called a tangent to the circle. Straight line ABC is a tangent to the circle at point P. Okay, let me change the diagram. So this is your line ABC, right? To this circle, it's being tangent at point B, right? All of this is something that you guys have to know. So please pause. You can write it down. Laws of motion, you guys can write it on your own briefly. And yes, this is something that you guys have to write. You can be lazy about the about to because you already studied that in a lot of detailed manner. This is something, this is new to you guys. So please see to that you pause and copy this.